Hi everyone. Today we're going to be looking at the life cycle of stars. So every star is a beginning, middle, of end. Basically what I'm saying is stars are born and stars eventually die off. And the life of a star can be billions of years. So this is not something that happens overnight. Our current star, the sun, it's been around for, I think, something like 4.5 billion years, and we have well over 10 billion more years to go before our own star eventually dies off. So keep doing your homework, keep checking EDSB. We're not ending anytime soon. Changing today's note up a little bit, I left a few blanks that I'm going to have you go and find yourself. So the star begins as a nebula. So you can research that, Google it, whatever, and write in your own definition of a nebula. As you can see, very beautiful. And likewise with it, the next step would be the protostar. So I'll let you fill that blank in as well. Now, as the mass of this protostar increases, the force of gravity increases. The bigger something is, the more mass it has, the more gravity. And the atoms in the core become so tightly packed that something called nuclear fusion begins. Nuclear fusion is when the nucleus of an atom fuses with another nucleus of an atom, and we get a whole different atom types. So in the case of our star is made up of hydrogen, and we are about 75. Our star is about 75% hydrogen, 25% helium. So what happens is the our star being made up of hydrogen, these atoms fuse together. Their nucleuses fuse together. This is something that takes huge amounts of heat, huge amounts of force, in this case gravity. It's not something that's happening on Earth. And they are fusing together to produce hydrogen, or sorry, helium. So as this hydrogen atoms fuse to form helium, huge amounts of light are given off, huge amounts of heat are given off. Hence why our sun and all stars are so bright and so hot. Now, what determines how long our sun has to live is basically how much hydrogen it has. Once all the hydrogen has fused with itself and formed helium, we are kind of looking at the end of our sun. So as I said, right now we still have 75% of our hydrogen going through this process. Now, the life of a star is determined by its mass. The bigger the star, the more gravity it has, the faster fusion actually happens. So large stars have a shorter lifespan. Smaller stars with less gravity, fusion happens slower, so they have a much longer lifespan, and we are kind of right in the middle. We're not big, we're not small, or our sun isn't anyways. The star's mass also determines its brightness, its color, and its size. So here's a Hertzsprung-Russell diagram, and this is a graph that shows the properties of stars. We can see along the x-axis here we have temperature, and basically along the y-axis we have the size. And you can see that most stars follow kind of a linear pattern here, or near linear pattern. Our very big stars, they are blue in color, and they are very, very hot. Now, just paying attention to the y-axis here, increasing temperature is closer to the origin in this case. So this is a diagram, it's not an actual graph. And over this side, we have less temperature. So cooler here in the red, warmer here in the blue. So going back to our diagram, we can see that big stars tend to be blue, and they tend to be hotter. At the other end of the spectrum, we have smaller stars. They tend to be red in color, and they tend to be cooler. By cooler, we're still talking millions and millions of degrees, but relative to the big stars, they are cooler. And then in the middle here, we have these yellow stars. And I think right here, there's our sun. So as you can see, we are not small, not big, and we are yellow in color. We're in the middle. Off to the side here, these are stars that tend to be being born or more on their way out of their lifestyle, out of their lifespan. So the main sequence, as you can see, 90% of the stars, including the sun, form that narrow, almost linear band from the upper left to the lower right. And these stars are in the stable part of their life cycle, sort of the middle of their life. Now, when we start talking about the death of stars, the death of stars happens depending on, or how it happens depends on their size. So let's start with these low mass stars here. So these are stars that have a mass that are less than the sun, and they are known as red dwarfs. They consume their hydrogen over a very long period of time. So these stars last a long time, and eventually, when the process of nuclear fusion has started to come to an end, they cool into small dim stars known as white dwarfs, and you can see one there. Now, medium mass stars, so this is stars like our star, the sun. They consume their hydrogen over a shorter period of time than the low mass stars, but still a long time. And when the hydrogen is used up, the core of our sun will contract and the outer layers will begin to expand, forming what is known as a red giant. And eventually the outer layers disappear off into space, and our sun will become a white dwarf as well. And finally, the high mass stars. These are the stars that are 12 times or more greater than the sun. They consume their hydrogen much faster than medium stars because of their immense gravity. The core heats up to a much higher temperature and iron forms in the core. As the iron cannot release energy through fusion, the core collapses violently and fusion stops. And I'll let you research and look up the definition for a supernova. Also, a good song by Oasis. Actually, that's Champagne Supernova. So supernova, when the star's remaining core, this is the star's remaining core after going supernova, it has one of two outcomes. So when a large star goes supernova, one of two things is going to happen based on the mass of the original star. And look how beautiful those things are. So the first outcome is a neutron star. And this is the result of a star that was originally between 10 and 30 solar masses collapsing. And I will let you find the definition for a neutron star. And the second is a black hole. And once again, I'm going to let you find the definition of this. Now, the one thing I do want to talk about with the black hole is I don't like the name of it. Students and people seem to think that it's a big hole into space that sucks things in. A black hole is not this. A black hole is an area in space that is so dense that its gravity is so strong that not even light can escape it. So a black hole is sort of the opposite of a hole. There's something there, and it is the force of gravity of that space is so great that not even light can escape it. So because light cannot escape it, it appears to be a dark region of space. It appears to be a black hole. It's not a hole, that's for sure. And these result when a star's of more than 30 solar masses collapse. So you can see here a black hole. Once again, it's not a hole. You're not going to fall into it. Light cannot escape it. And because light cannot escape it, we cannot see what's there. So here's the life cycle of a star. Starts as a solar nebula, and it can take different paths. Our sun, the average star size, as nuclear fusion starts to stop, we will turn into a red giant, and then into a planetary nebula, eventually ending up as a white dwarf. Where much bigger stars, you can see here they're blue in color, they will become a red supergiant, and eventually they will go supernova. The smaller ones, after going supernova, will become a neutron star, where the big ones after going supernova will become a black hole. And just a little bit more information on these processes are found in these YouTube channels. So please peruse those and feel free to go down the wormhole, so to speak, and do some additional research based on your own interests. Have a great day, everyone.